So take this constant A, okay, the constant A, and multiply it with, say, sine theta or cosine theta. Choose anyone, sine theta or cosine theta, both would work actually. So in other words, let x is A sine theta. So what would be the dx actually? Okay, dx by d theta. So dx by d theta is going to be A cos theta. In other words, the dx will become A cos theta d theta. Okay. By the way, and then make the substitution on the place of wherever you see x, just substitute these values. So if you have a square minus x square dx, so the a square minus x will become a square sine square theta, and dx will become a cos theta d theta. Okay, this is what it will become. Okay, no. Yes, dx is a cos theta and d theta. So what are you going to do? So if you simplify this a little bit, so you're going to say this is a square minus 1 minus sine square theta. So this trick will always get rid of this square root sine actually. That's what the beauty of this trick is. So a square 1 minus sine square theta, and this will become what? So a square 1. So this will become a square cos square theta. So its square root will be a cos theta actually. So the a cos theta multiplied by a cos theta and d theta. And you can simplify it a square and cosine square theta and d theta. And then I know how to solve such integral actually. Okay. So in other words, your complicated square root function with constant square first minus variable square. Constant square is first and then variable square. Just take x as a, in other words, whatever is this underlying a multiplied by sine theta, or you can also take cos theta. It's not going to make any difference. You're going to get always the same result. So what can I do with the cos square theta? So I can do that the cos square theta is 1 minus 1 plus cos 2 theta divided by 2 and d theta. Okay, that's what it is going to be. And if you simplify a little bit more, you take this 2 out, so you're going to get a square over 2. Okay, a square over 2, and the integral of 1 will become theta plus integral of cosine 2 theta will become sine 2 theta divided by 2 plus constant c. Okay, this is what the integral of this will become actually. So then what you can do, you can convert now, wherever you have theta, you can substitute back its value and you can get an answer actually. So there are several ways in which you can do it. So in other words, this result is in theta while I need a result in the terms of x actually. So one trick is this, that okay, since my x is a sine theta, so therefore x over a is going to be sine theta, and therefore the theta is going to be really, what do you call, sine inverse x upon a. Okay? Sine inverse x upon a. And then wherever you have theta, just substitute sine inverse x upon a, and that is going to be really your answer. But to get even a more, symmetric and suitable form, what you can do is that I know that what is the formula for sine 2 theta. So that sine 2 theta is 2 sine theta cos theta plus c and divided by 2, so you can get rid of the 2 and 2. Okay? And then you can substitute the value of theta. You can do one step ahead actually. Okay, so the x is a sine theta. Okay, x is a sine theta. So the theta will be sine inverse x upon a. So this is what one of the result. Okay, so on the place of theta, substitute sine inverse x upon a. What would be sine theta? What would be the value of only sine theta? So it's going to be x upon a. So here you have sine theta, substitute x upon a. So what should I put in the place of cosine theta? I know that cosine theta is square root of 1 minus sine square theta. Okay, 1 minus sine square theta. So on the place of sine theta, you can substitute again x over a. So you're going to get 1 minus x square over a square. And if you simplify this a little bit more, take LCM, so it's going to be a square minus x square divided by a. Okay? So now you have a very concrete format. So making substitution back into these formula would give you what, for example? Now we have value of theta, we have value of sine theta, we have value of cosine theta, substitute them back. So when you're going to substitute them back, what you're going to get? So you're going to have a square over 2 sine inverse x over a plus sine theta is x over a multiplied by a square minus x square over a plus the constant c. Okay, plus the constant c. Now, if you have, for example, so if you simplify this a little bit more, you can write this as x square over a square. And if you multiply a square by 2 with the both terms, the first term will become a square by 2 sine inverse x over a plus a square and a square will get cancelled, so you're going to get x over 2 square root of a square minus x square plus constant c. So this is really the integral of a square minus x square dx. So a square by 2 sine inverse x over a plus x over 2 and the square root of a square minus x square plus constant c. This is really the integral. Okay? So while you are solving next time such integral, you can directly use, for example, this formula actually. Or maybe you will be given, for example, the table of integration of such formulas in which these formulas are known, and just use them to compute the integrals actually. So for example, if I say, what would be the integral of say 4 square minus x square with respect to dx. Then using this formula, okay, then substitute say a equal to 2 in this formula. So when you're going to substitute a equal to 2 in this formula, this will become 2 square, mean the 4 divided by 2. So this will become 2 sine inverse x over 2 plus x over 2 times the square root of 4 minus x square plus constants. Okay? Square root of 4 square minus constants. So if you have been given, for example, a table of integrating such kind of expression, it's not difficult to, compute such integrals actually. Okay? It's not difficult to compute such integrals. One thing that I would like to do or give you as an exercise, what if you have this situation, dx by a square minus x square actually. How are you going to solve this? I mean, you have two ways of doing it. One way is we already know basically one formula, okay, that the derivative of 1 minus x square dx is sine inverse x plus constant c. Why? Because the derivative of sine inverse x is this. So you can convert this into such a form and then apply the formula. So how can I convert, say for example, this into such a form? The way to do it is, for example, that take a square common from the both term actually, or pull the a square, factor a square out. So when you're going to factor a square out, this will become what? 1 minus, there is no a square here, so you're going to have x square over a square. This is what that you're going to get. X square over a square in this cube. And if you simplify this a little bit more, this a square will come out of square root. So this will be in, dx divided by a. So if you wish, you can keep this a outside of the integral. And what is going to remain is dx by square root of 1 minus x over a square. So you can put the both squares in the single term actually. You may also interpret this formula is that if you have 1 over 1 minus what do you call W square, you can put a W here. So this is going to be the sine inverse W. So what would be 1 over 1 minus x over a square? So by this formula just replace W by x by a. So you're going to get, what do you call, 1 over a and sine inverse x over a plus c. So this is what really is the integral. If the expression for a square minus x square is in denominator actually. Okay, is in denominator. So you can easily compute these integrals. What is the next thing? Okay, so what we saw so far is that if you have a situation like a square minus x square in your integral, then x equal to a sine theta or a cos theta would work. But, okay, so I'm not getting into the details of the integral, but if your integral involve a square plus x square type term, then x equal to a tangent theta substitution would work. Why this would work? Because if you will compute say a square plus x square, you're going to get the square root of a square plus a square tangent square theta, and this will become what? A square 1 plus tangent square theta, and this will become, I know that 1 plus tangent square theta is secant square theta, so this will become a secant theta. In other words, your a square plus x square type term will convert into a very simple term, a secant theta. Okay. How about if you have x square minus a square type term involved in your integral, then what should be my substitution? Then the kind of substitution that would work is x equal to a secant theta actually. A secant theta. Why this substitution would work? So this substitution would work because if you compute x square minus a square, this would be a very simple expression. How? So this will become a square secant square theta minus a square. So hence this will become a square secant square theta minus 1, which is same as a square tangent square theta. So this will become a tangent theta. So your such expression will be converted into a tangent theta. So in other words, if your integrand involve, these substitution, these are such kind of terms, please use these substitutions. This here, and in such case, this substitution. It will radically simplify your integral, and you can solve the integral easily in the terms of trigonometric integrals actually. Okay. So this is what is the one thing. Then I would like to talk about a final technique of integration. There are several techniques actually, okay, of solving the integrals. You guys are programmer, even you can compute the integrals numerically. I mean, if you have, you can write a small code, and that code can compute the definite integral for you actually. So there will be some time in the end of the course we will discuss such codes as well actually, that how to compute such integrals numerically. You don't have to always do the lengthy calculation. Okay? Okay, so the next is really about solving the integral which involves the fraction in algebraic polynomials. Okay, so if your integral involves a complicated algebraic fraction, then how to solve such integrals actually. Okay, for example, I can say that imagine you have this integral 5x minus 4 divided by 2x square plus x minus 1 dx. Okay. So how to solve such integral? Making a substitution, would that work? If you, for example, differentiate this, so you're going to get 4x plus 1. So here you have 5x minus 4. So what should I do? I mean, you can do it directly with some trick actually. That okay, you split, for example, this integral into two integrals, 5x, which is 2x square plus 4, okay, or maybe another trick could be that, okay, so if this integral is 2x squared plus x minus 1, so what would be the derivative of it? It's going to be 4x plus 1, okay, it's going to be 4x plus 1. So I don't have a plus 1 here, but you can bring it. It's not a big deal. You can bring it. Okay, so let's move on to another very interesting kind of integration technique, which is called integrating through the partial fractions. And what you do in this case, what you have been given most of the time in this case, that you have to integrate kind of an algebraic fraction actually. And the trick for solving such integrals is first to simplify those algebraic fractions. So if you can simplify those algebraic fractions, the integrals would be much more easier actually. For example, let me give you an example. So one example is, okay, 4x minus 5 over 5x minus 4, doesn't matter, 5x minus 4 divided by 2x squared plus x minus 1 dx actually. So you have this integral and you have to simplify it. So one way is that, okay, you can think of making a substitution, but the substitution is going to give you 4x plus 1, but we have a 5x minus 4. Though it's not difficult to convert it in the form of a 4x plus 1 actually form, okay, but you can, but that would still lead to a complicated integral actually. So if you have such kind of an integral in which you have, you know, some algebraic fraction actually, so in other words, a fraction in which numerator is a polynomial and denominator is a polynomial, then what to do? Okay? Then what to do? The trick is, before solving the integrals, let's play with, what do you call this integral, this integrand actually. Okay, this integral. So the first thing that you have to do, for example, in order to solve or do the integral of such integrand, is to simplify this fraction actually. And what is the way of simplifying this fraction? So the first thing could be that, okay, factorize, for example, numerator and denominator and see that is there something that is cancelling out? The answer is, let's do it and let's see that what we get. So if you're going to simplify this, 5x minus 4, so this will become what? So this is 2x squared plus x minus 1. So you can simplify this to be 2x squared, say, plus 2x minus x minus 1. I hope you all know how to do such manipulations. And when you're going to simplify this, what you're going to get? So from here, you're going to get 2x. And from here you're going to get minus 1 multiplied by x plus 1. Okay? So I'm not going into the details of how to do this algebraic manipulation. I'm assuming that you know it. So this will become what? So this will become 2x minus 1 times x plus 1. Okay? So I factorize the denominator. Is some simplification is possible? I mean, the answer is not in such form actually. Okay. Then what essentially you have to do is simplify this expression. You're going to say that, okay, wish you could break such fraction in the form of, say, this kind of a fraction. Means it's something divided by 2x minus 1 plus something divided by x plus 1. So if you can separate them, then doing the integral would not be difficult actually, because